at the top of page 574, you can write these notes, which we just talked about in the last example. How do we do a general solution when the domain is everything? Theta belongs to the element of all real numbers. Well, we're going to first solve it like we've normally done, from 0 to 2 pi. Then to each answer that we have, we're going to add 2k pi. And that adding 2k pi, where k is an element of the integers, that's basically saying every coterminal angle with the angle that you started with. So I'm going to show you graphically what this means with a very simple example. Something that we know before we get to our next example. You don't have to write this down, but I'm going to draw a graph. You tell me what graph this is. Oh, you guys are quick. Excellent. So this is our sine graph. And it would keep on going, right? So if you were solving this equation, when does solve for theta, ooh, that's purple, solve for theta, sine of theta equals 1/2 over all the real numbers. What that would mean graphically is on our graph, we would have to find out where 1/2 is. It's right here. If I draw a dotted line across here, and I imagine that dotted line going on forever, how many times would it intersect our sine graph? An infinite amount of times. What's this first time that it hits it? Pi over, it's not pi over 4. When is sine equal to 1/2? What family? Pi over 4 is root 2 over 2. Pi over 6. So that's our one answer. When is our second answer? What's this one? What quadrant would that be in? Quadrant 2, because it's also positive in quadrant 2. 5 pi over 6. Those are the two answers from 0 to 2 pi. Can you see from 0 to 2 pi, we only have those two answers. Only quadrant 1 and quadrant 2. But if we would hop by 2 pi's, can you see if I hop from this one by 2 pi, I'll get to there. And if I hop by 2 pi on this one, I'll get to this one. And if I keep hopping, you'll keep hitting more points that line intersects. So the way that we would write this answer is our final answer, theta is equal to, we would take both of these answers, pi over 6 and 5 pi over 6, and we would add 2k pi plus 2k pi. This straight line just means where, or such that, where k is an element of the integers. So we have two answers, and we have all the coterminal answers that go with them. So this is a simple example and showing you why graphically that happens, because where it's equal to 1/2 would intersect over and over and over and over again. So we're going to get some questions that are non-calculator, some that are calculator. Here's our first one. Solve for theta. Ooh, maybe I'll move it down a little bit to start with. This one would be calculator. First of all, we get sine by itself. That would give me -1/7. I then have to find my reference angle. How do you find a reference angle? You go to your calculator. Make sure you're in radians. I'll go sine inverse. A reference angle is always with your positive values, so even though that's -1/7, I will do sine inverse of 1/7 to get my reference angle. Once I've found my reference angle, I have to think Sine is negative. What quadrants does that happen in? Quadrant 3 and quadrant 4. So to figure out our angles first between 0 and 2 pi, I'm going to have to figure it out in quadrant 3 and in quadrant 4. To figure it out in quadrant 3, I'll go pi plus my reference angle. To figure it out in quadrant 4, I'll go 2 pi minus that reference angle. And those will be our answers between 0 and 2 pi. Now, as far as our steps, right, our steps for the general solution, we did step 1. We solved it like normal from 0 to 2 pi. Step 2 is just a formality. Step 2 says, now that you've solved it between 0 and 2 pi, take both of those answers and add 2k pi to them, where k is an element of the integers. And since these were rounded values, we're going to use our approximation sign there. So the only thing new today is plus 2k pi. Everything else you've done before. You've solved for theta. You've solved for theta with your calculator. You solved for theta with exact values. You know what quadrants it's in because of the cast rule. So the only thing new with the general solution is adding the 2k pi. Want to try one more? Find the general solution for 5 cos theta plus 1 equals 0. So you get cos theta equals 1/5. You would have then found your reference angle. Here, let's show the work in between. Cos theta equals negative 1/5. Our reference angle would have been, go to your calculator, second cos of positive 1/5. Get a reference angle of 1.37. And then using that reference angle, cos is negative in quadrant 2 and quadrant 3. In quadrant 2, you'd have got 1.77. Quadrant 3, you would have got 4.51. Add the 2k pi, and you have your answers. So, questions for practice. This was, instead of doing example 1, we did these examples instead, so we're going to skip example 1. But you can now do 5, 6, and 9.